What if I told you that AI has made it so that a solo game developer can do the work of hundreds? And I'm not exaggerating either. Take a look at the credits for games like Until Dawn, The Quarry, and Detroit Become Human. These are all interactive story games that have over 1,000 people credited to have worked on them. All of these employees are there for one reason, and that's to support the actors and actresses to bring a story to life. As an indie dev, we have no choice but to collapse the entire production hierarchy and become a one-man army. Our goal is simple: to make a similar game solo or as a small team with an indie budget.
You're looking at enough to get us started, $2,184.
But movies cost millions of dollars to make.
That's after gross net deduction, profit percentage, deferment, 10% of the nut. Cash, every movie costs $2,184.
Here's why it's possible. Gameplay-wise, these games are incredibly simple. Walk around, interact with stuff, perform quick-time events, and choose dialogue options. Obviously, the bottleneck is entirely in cutscene content creation, which AI has recently made substantially easier. I'll prove it to you. I recorded some audio in an echoey bathroom with a fan blowing, and look at the result I was able to get with AI tools. I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched sea beams
glitter in the dark near the Tannhauser Gate. All those moments will be lost in time, like tears in rain.
This is absolutely insane. You no longer need a sound studio or fancy equipment to voice act your game. Of course, audio is only one component. That still leaves the motion capture, which I'll get to in a bit. I'll be going over my equipment, workflows, as well as all of the different AI tools that I'm using to go from motion capture to cutscene in under 10 minutes. The game I'm working on is called Pantomime, and it's an interactive story game designed to teach English. It's currently just me and my brother working on it, and this is the type of result that we're able to get. Obviously, these results are not quite as good as the AAA games I've mentioned, but they aren't bad either. Just 3 years ago, an indie dev couldn't even dream of making a game like this. I know because I tried, and I had to abandon the project almost immediately from hitting wall after wall. I would have needed to hire voice actors, writers, buy expensive mocap equipment, hire artists to build motion capture friendly characters. When you can't get started without outside funding, that's generally a good sign to move on to a different project. And I'm glad I did, because fast forward to today and all of a sudden it's entirely possible to make a game like this on an indie friendly budget. The first breakthrough that you're probably already aware of was Epic Games releasing MetaHumans. These are realistic humans that are already set up for body and face motion capture. Epic even created the LiveLink app that uses iPhone AR depth sensing data to easily capture and animate faces. Because we're a small team, we need to be able to iterate rapidly. Like I said earlier, our goal is to get the mocap into a cutscene in under 10 minutes. That means recording face, body, and voice simultaneously and importing it fully into Unreal Engine and getting it into a cutscene. Obviously, we're going to be transforming the voice with AI to allow voice acting any character, but more on this later. First, we need to figure out logistics. Face is easy. As mentioned earlier, we'll need an iPhone with AR depth sensing cameras. This means anything from an iPhone X to the latest model. This will cost you at most $1,600 if you get the latest model with maxed out storage, but obviously you can save quite a bit here if you grab an older model. Let's throw in a Rokoko head rig for another $300. Now in my case, I had an iPhone 14 Plus, which is actually too large for the head rig, so it ended up being too close to my face to capture good data. To fix this, I unscrewed and inverted the head rig mount to get the phone a little further away. Doing this does block the screen a little, but doing this doesn't interfere with recording, so I was fine with it. If you have a normal sized iPhone, then you don't have to do this. Next is audio capture. I mentioned that LiveLink records audio, but the iPhone microphone quality is actually so bad that even AI can't fix it. However, we have to be very careful about what microphone we choose. If we get a battery-powered standalone microphone, now we have to manage another piece of hardware and match all of the audio files from that to the face motion capture on our phone. This is a nightmare, and we want to avoid this at all costs. There is a clever solution, and that's to get a better mic that plugs directly into the phone. I'm personally using the Shure MV88 Plus video kit, which costs $250. This comes with both USB-C and Lightning cables, so it'll work with any phone. We won't be using the small tripod it comes with, however it does come with the clamp needed to secure the microphone to your phone. Now, is this microphone AAA quality? Obviously not, but it picks up enough of your voice so that the AI can enhance it to AAA quality. For denoising the mic audio, I recommend either Resemble Enhance, made by Resemble.ai, or Ultimate Vocal Remover 5. Both have user interface versions as well as Python libraries so that we can automate the denoising process. I prefer Resemble Enhance, but I'll be sharing the scripts for both in the Git repo I've made public. It's worth noting that Resemble Enhance has both a denoiser and an enhancer, but we'll only be using the denoiser. The enhancer quality is honestly pretty mid right now, so we'll be using a different tool for this later. Before we get to that, we're going to be using a speech-to-speech converter. I recommend either Respeecher or 11 Labs. Take a look at how convincingly Respeecher converted my voice in this cutscene.
One small problem. How do we get down?
We'll climb down. Look, there's a rope.
Both of these services are really similar and have free demos, so I recommend playing with both and seeing which you prefer. Both of these have high-quality voices and APIs to help you automate your speech-to-speech conversion, and as before, I'll be sharing the scripts for both of these in our Git repo. We personally go with Respeecher, which costs about $75 a month for all of the features we need, coming out to about $900 a year. Compared to how much it would cost to hire multiple voice actors, this is actually a pretty good price. These AI tools can be pretty hit or miss, so that's where an enhancer comes in. If the quality is still lacking, we can drag the audio into Adobe Enhance, which is a free AI voice enhancer. There is no API for this, so just know that if you use Adobe Enhance, it will slow down your workflow just a little bit. Since we're making a video game, we need to be a little careful with the strength. If it's too strong, it may sound podcasty because that's what this tool was designed for. As always, play with it and see what works well for you. Also, if anybody knows of a Python scriptable voice enhancer at the same quality as Adobe Enhance, please drop a comment and let me know below. It would be nice to automate this. That leaves the last piece, body motion capture. If we use a camera-based approach like Move.ai, that means uploading footage to their cloud for them to process it. This would absolutely destroy our 10-minute budget because it takes a while for them to process this stuff. This is especially true if you add multiple cameras or phones because each of these increases the time it takes to process the animation. This is still a good option if you can't afford a mocap suit, you're just starting out, or you don't want to deal with the risk of owning and maintaining expensive mocap equipment. For those that need to move faster, I've been using the SmartSuit Pro 2 and getting decent results. Unfortunately, it's going to cost you $4,000 for the suit, gloves, and head rig bundle. And once we factor in the iPhone, microphone, AI speech-to-speech converter yearly subscription, this puts us at a little over $7,000 after tax. Honestly, the Rokoko animations always need cleanup. They have a $2,000 coil you can buy that's supposed to improve accuracy and reduce cleanup, and I ordered one months ago, but Rokoko is really bad at shipping things in a timely manner, so unfortunately I can't really say if this helps yet. There are plenty of other options as well, so I encourage you to do your homework and find the mocap setup that fits your budget. Now, after all of this, we still don't have simultaneous capture. You have to go back to your PC, start the body capture, then start your face capture, then go back to your PC to stop recording, and this is going to make you lose your mind. This is where a programming background really helps. Our goal is to create an entirely voice-activated workflow for simultaneous motion capture recording. The steps are actually pretty straightforward. My voice commands send a message to Unreal Engine, and Unreal Engine sends a message to Rokoko and LiveLink. A plugin in Unreal Engine serves as the central brain, making sure that all of the other software is in sync. We'll be sharing the source code for this plugin, but don't expect to download it and just have it work. This is more of a reference for how you would build your own system like this. First, I set up some shortcuts in my phone for all of the recording actions we need. Primarily, this is calibrating the body motion capture and starting and stopping recording. Unreal Engine has something called the Remote Object API, and this allows you to call functions in Unreal over a network, meaning that we can call Unreal Engine U functions from a voice command in our phone. So, let's set up the voice commands. First and foremost, we are not using Siri. Siri has problems with stealing focus from the LiveLink app, causing recording to stop immediately. Instead, we're going to be using the voice control accessibility feature. Annoyingly, everything is enabled by default, so we just go in and painstakingly disable all of the defaults so that we don't accidentally trigger them. Once all of these are disabled, we can add some new custom voice commands. These commands are set to only be active while the LiveLink app is running. All of the voice commands are prefixed with the word interlinked so that I don't accidentally trigger them while recording.
Interlinked.
Interlinked.
Once Unreal receives these commands, it needs to send a message back to the iPhone to start recording. Fortunately, LiveLink has a feature for this. Go into LiveLink settings and enable the OSC server and configure it to point to your PC's local network address. You can use my settings as a general reference, but obviously you'll need to put in your own local network IP. Okay, so now everything should be set up. Unreal's running with the plugin, we have Rokoko running, we have LiveLink on our phone running, it's configured properly. Let's hop to it. Okay, so first things first, we need to calibrate. Interlinked, calibrate. Interlinked, start recording. But we're playing. 5 more minutes. Interlinked, stop recording. Okay, let's get it into the engine. Once we're done recording, the process is actually pretty simple. We export the animation from Rokoko. We export the data from our iPhone. Then the plugin handles the rest. We import the body motion capture and select the metahuman we want to target it onto. And that's a one-click import. Then we import our face motion capture. This part was tricky to automate because Unreal's importer is not open source. So I had to abuse the Unreal Reflection system to partially automate it, and in the end it's much faster than doing this manually. Then we simply save that off. Next we import the voice data. This has to hit a bunch of machine learning APIs and run a bunch of scripts, so it takes a while, but once it's done, all we do is drag it into Adobe Enhance to do that final enhancing step, re-import it back into Unreal, and it's good to throw into a cutscene. So once it's all in the cutscene, we play it back. There's a little bit of a bounce in Emma, so now we need to clean that up, delete the keyframes, and the animation's good to go.
But we're playing. 5 more minutes.
And there you have it, from mocap to cutscene in under 10 minutes using AI and a bunch of automation. I hope those of you who want to become a one-man army, or even those on a small team looking to move fast, found this useful. And as mentioned earlier, we're using this technology to build a game to teach English. Now, obviously, if you're watching this, you already speak English. But if you know someone who's learning, please send them this game so they can wishlist it and follow our progress. It would be very much appreciated. Thanks for watching. Bye.